Um, okay, so I can do this. Wow, projector. Okay. So the first part of today is me just rambling about materials. You don't really need the slides, but I'm just going to be talking about different materials and material properties because it's a continuation that we did last week about 3D printing. Because there's a bunch of different materials that you can use when 3D printing. So depending on your use case, you might want to choose a material for your job. Just like if you pick like wood or metal for something you're making, you could do the same thing with different kinds of plastics. So I'm going to go over some of them. There's obviously more than I list them today, but these are just some like pretty popular ones. But yeah, the first one is PLA. If you're unfamiliar with it, it's technically like an eco-biodegradable plastic. But like not really. It is corn-based, so like that's why they say it's biodegradable, but it needs really specific like conditions for it to break down and decompose. So it's technically biodegradable, but it's like but it's very popular because it's very easy to print and it's pretty cheap. So you can get these like sometimes for like 15 or less for 1 kilogram. This isn't a kilogram, but you'll typically get filament for your printer on spools like this. They typically come in like 1 kilogram spools, but you can get them bigger, like 2, 3, or 5, sometimes bigger. But that's basically the material that you input into the machine, and you obviously have different kinds. So this is ASA. I'm going to be talking a bit about it later, but they all look very similar. PLA is also great because manufacturers have like a bajillion different colors. So if you like colorful things, then PLA is typically a good choice. The main downside is that it has low temperature resistance. So if you have anything that needs to be like withstand like warm temperatures outside, maybe like sitting in your car for a while, and like if it gets sunny, like on a hot day, the car can get pretty hot, and your printer can tend, or the PLA parts can tend to warp when it gets warm. So if you need something with higher temperature resistance, this usually isn't your choice, but it's pretty good for like things inside like desk toys and organizers. Again, because it's cheap and it's really easy to print. Also mechanically, it's pretty good. It's actually a very rigid material, so if you're like after rigidity and you're not really worried about temperature, then this is another good choice. So yeah, it's very popular. I don't really print it, but a lot of people do. ABS is something that's becoming more and more popular, mostly because the printers are getting better and it's easier to print now. ABS is a lot higher, has a lot higher melting point, and it can withstand a lot more heat. So one example is like I have a car and manual swapped it. So like to put the manual transmission in, then you need to add a third pedal, and there isn't a spot for it in my car, right? Because it wasn't designed for that. So I printed ABS parts that went into my engine bay to space out like the or the clutch master cylinder. And it's been in my car for like over 2 years, and it's been fine, right? And it's been in my engine bay. It's not touching the engine, but it gets quite warm there. So like ABS is pretty great. It has pretty good temperature resistance. That's why I'm printing it. And that's why I have this. So you want to have, you typically want an enclosed printer for ABS because it tends to warp. I talked about warping last week where it like will curl up and stuff, and ABS has a tendency to do that if you don't have high ambient temperatures. So this has like insulation and stuff like that to make sure it's nice and toasty and it prints pretty nicely. But yeah, just keep in mind stuff like this is like, I mean, all material that you print kind of like exudes like hazardous like waste. Like you can probably smell, yeah, fumes. Sorry, that's the right word. You can smell it, and ABS is particularly smelly. So you might want to keep that in mind. Like print in a really well ventilated environment, like all the time, but especially for materials like ABS. ASA isn't on this list, but mechanically it's very similar to ABS. But its main advantage over ABS is that it's UV resistant. So if you have like injection molded toys, a lot of them are made of ABS, including Lego and stuff like that. So if you ended up needing it outside, you'll see like they tend to degrade or turn yellow over time. That's because they're not really UV resistant. So if you want something outside, ASA is pretty great. It's very similar to ABS, which is partially why I print it so often and printing it today.
And we'll have the choice to choose what kind of material.
I'm going to print whatever I can get. Typically, I get a little ABS and everything. So, yeah, this is mostly for your information. If you get your own printer or you ask someone to print something, then they can kind of cater their materials towards whatever you need. But yeah, it also depends on their printer's capabilities. But lots of printers can print ABS nowadays, so pretty great. It used to be really hard to print, but yeah. PTG, I would say, is probably the second most popular filament today after PLA. And it's kind of a middle between PLA and ABS. So it has a little bit more temperature resistance. It's not quite as temperature resistant compared to ABS, but it won't like melt in your car. So I left stuff in my trunk over the summer under PTG, and they were totally fine, and they were just like baking all summer. But my friend left stuff in his trunk and his PLA, and it got all like warped and stuff. So if you want something a little bit like more temperature resistant, but you don't have like ABS setup, PTG is like a pretty good material to go for. Almost all machines now print PTG. The main thing you need to watch out for is it's very susceptible to moisture. So you'll see here I have a dryer, and it's because Indiana can get kind of humid sometimes, and some materials really like to absorb moisture. And when it does, the moisture will boil out of the nozzle as you print it, and then you'll get bad surface finish and sometimes a weaker part. So it's important to dry your filaments, especially those that are most susceptible, like PTG. But like PLA is not as bad. You can typically get away with not doing it. But yeah, keep that in mind. Um, yeah, you can't see these numbers, but you can, if you look at the slides, you'll see like the temperature ranges kind of is increasing here. But yeah, should on this TPU. Anyways, there's like as you can, if you felt that ASA spool is kind of like a rigid material, and that's what most 3D printer filaments are kind of made of. It's usually pretty rigid. But TPU is unique because it's very flexible. So, like these are some like the benchies that we sliced like last week. I printed one PTG and you can like squish it. It's pretty fun. I did not bring a PTG benchie. Yeah, my roommate's form of testing how strong the material is throwing it on the ground as hard as he can when you give him a benchie, and it just kind of bounced around the house. So it's pretty funny.
That's flexible, but it retains the shape.
Yeah, so like you can squish it and then like it'll come back. If any of you are into battle bots, a lot of people print it like who 3D print their battle bots in like the Amblin class use TPU for their shells because they're so flexible, they're very impact resistant, so they can take a lot of abuse and like their battle bots can last a long time. So again, different use cases, different materials. It's pretty fun stuff. Typically for TPU, you have to print a lot slower just because of how flexible the material is. It used to be a big challenge back in the day, but it's not really the case anymore. Yeah, most machines can print it. So yeah, it's pretty cool. Um, Now we're getting into kind of like the more engineering territory of materials. So on this slide, I'm talking about nylon. Nylon's in a lot of more like engineering grade stuff. Like I think like some injection molded parts for guns are made of glass filled nylon. So it's a polymer. It's still like a plastic, but it's very strong. It's very good. But you can print these on 3D printers as well. materials that I'm talking about are materials that used to be injection molded and still are, but because the manufacturing process for the 3D printer fundamentally is very similar, we benefit from all the advancements from injection molding.
Are some of these materials like controlled?
Control, like
Yeah.
what you can buy.
Yeah, because at least in Brazil, kind of like a chemical that you can use to purify drugs, like acetone, you can control.
Because these like 3D printers are pretty unregulated right now, and you can kind of print whatever you want, and you can get really good materials. If you're worried about like the ghost gun stuff, it's not really quite there yet. Like you can make ghost guns, but they're not like that good. But you know, that's just kind of like how 3D printers are. You can kind of make whatever you want. So it could be a blessing or a curse. Like I don't use nylon, but I use like other engineering grade materials for stuff like my car. So like, obviously it has non-malicious use cases. And nylon is like, it's a pretty common material. So yeah. But yeah, nylon's pretty cool. The melting temperature is quite a bit higher than the other ones we were talking about today. It's typically a little bit more expensive because you're kind of going into the engineering grade materials. It's pretty cool. The other problem about it is that, again, it's susceptible to moisture like PTG, but it's a lot worse. Like you have to be printing while actively drying or else it can absorb moisture depending on your environment. So it's a lot more picky, but it's a great material. A lot of people will mix like these nylons with carbon fiber, so you have like a carbon fiber nylon or glass fiber nylon for extra rigidity. So yeah, it's pretty cool. I have a spool of it, but I haven't tried it yet. I'm very interested to see how it does. Um, Polycarbonate is the next thing on this list. It's kind of out of scope for most desktop machines just because of like how hard it is to print it. Pure polycarbonate is very difficult to print because you have to have a nozzle typically over 300 degrees Celsius and you have to have really high chamber temperatures. If you're curious what polycarbonate is, it typically is like the material that you use for bulletproof glass. So it's a very strong material and you can 3D print it. Technically speaking, it's very hard though, but it's pretty awesome. Yeah. The next slide, if you're looking at the slides, is just kind of like an overlap of all the different material properties. This is just kind of showing you that, like, depending on your use case, it's a good idea to pick the material that you need for your project or whatever you're making, because you can cater these to have the right properties that you're looking for. Especially with additives like carbon fiber and stuff, you can add more rigidity if you want it and stuff like that. So it's pretty cool. But yeah, are there any questions about material stuff?
Can you print blends? Or do you have to, can you print blends?
Blends?
Or you would have to buy?
Like some machines have like multi-material or multi-color capabilities. So this one, I'm working on it right now. It's not quite finished, but like this has the ability to like change the material while you print. But because it's a single nozzle, it typically like you can get contamination.
Yeah.
So other machines will have like more than one nozzle, or they'll have a tool changer that will like turn the nozzle and pick something another one up. So those are pretty cool. I want to make one, but they're kind of expensive. But a company is like coming out with one that's like pretty affordable, relatively speaking. So that kind of stuff is coming. I'd say that's probably the next big advancement for 3D printing because most companies have, at this point are kind of locking in like multicolor, but now we're kind of moving towards multi-material. And it's sometimes nice because like remember we were talking about supports yesterday? Or not yesterday, last week, sorry. But like last week we were talking about supports. Yeah, and there's some materials that don't stick well to each other. So if you have like a multi-nozzle tool head for a printer, you can print like your main part on one material and then your support on another material, and then the materials or the supports just fall off, and it's really nice. So, that stuff is hopefully coming.
I mean, people have
and blending different cells and like media to 3D print, more like tissue and
Yeah,
things like that.
typically, like these materials is
Exactly.
found in the soil and it's all the same material. But if you have that type of capability, you can kind of mix stuff. Like people might mix like a TPU, which is like a flexible, and then like a rigid material. So you could have one piece made of multiple materials, and you could have like a flexible hinge that's one piece. So that kind of stuff is pretty cool.
I think Stratus has a printer that does the multiple too.
Yeah, I'm sure they do. Stratus has been around for a while. They're typically more like industrial focused, so they have like these giant machines that are like
See one, and then they have like a dump tank.
yeah,
You can put the part in there, and then all the support like launches
yeah,
out.
it's pretty cool. Yeah, Stratus does a lot of cool stuff, but it's typically like out of reach for normal like students and people like us. But for companies, like 3D printing is becoming a more viable option for manufacturing stuff, which is pretty awesome. But yeah, any other questions? I know it's like a big ramble just about materials. So. Cool. If you're curious, like there are function services at Purdue. I forget what all these names for, but some of them I think do. There's like a 3D printing club and stuff like that on campus. I think Bechtel has it. I forget if it's still open to everyone. But yeah, there's a bunch of services. Also, if you know someone with a 3D printer, they're usually more than happy to print stuff for you, including me. So if you need stuff printed, feel free to let me know. Yeah, you can print stuff even if you don't have a printer most of the time. You can also pay people online. There's like 3D printing services that do that. So yeah, it's typically more expensive than finding someone locally. Yeah, so that's kind of it for the material side. We're going to move towards rendering, which is kind of where you want to have your computer now. So you did save your battery. Now's a good time to open it. Yeah, I assume both of you already have it open. Yeah, this is the final part for your final project. It's basically just rendering. So if you watch ads, like and you don't have an ad blocker like me, you sometimes see like products like flying around like through your screen and stuff, and they're typically not like actually there. They're typically like renderings, right? They're not real, but they're simulations of the model or whatever they're trying to sell, and it looks really nice because it's rendered. So what we're gonna do is we're gonna be making renderings today. We're not gonna be doing like animation and stuff like that, but we're gonna make nice like still renders to make really nice photos of your final projects.
No animation. Do you think you can put a video on how we can do animation?
Do what?
Animation?
I don't know if Fusion has animation capabilities. I need to check.
I'm trying to spin the wheels for some reason, but I cannot.
Oh yeah, I mean you can like if you're moving it in assembly, you can do it. I need to check to see if you can like animate full render. I think you can. I've never done it.
Metric animation. Is it metric?
Yeah, probably. But yeah, basically we're gonna kind of take a frame or a snapshot, and then we're gonna send it out to the cloud, and then have Fusion or Autodesk render it for us, and it's gonna get sent back. So remind me later about the animation. I'll look into that. But, yeah. Okay. So basically, you just want to open up a model that we've made in class already. So if you want to open up an old homework assignment or just something with a 3D model that we've done in class, I typically do the Lego car, but I might switch it up today. Yeah, it's pretty quick. Let's see. You make sure that you need to make sure the heat is still on because it has to preheat.
Trying to cool. Yeah, no, I
Okay. So if you have Fusion up, great, mine's frozen. Um, okay. So who hasn't gotten Fusion open yet? All right, sweet. Okay. So basically, um, typically we've been working in this design workspace, which is in the top left corner. It says design. To render stuff, you just click on that, and then there's a render drop down. You can see there's a couple other things here, including animation. So maybe that's probably where you would animate parts. But you can also like simulate stuff, which is kind of covered in the NDA. But we're doing rendering, so it's like the third one down after generative design. Um, and then you'll kind of be moved into a different workspace. You'll see your toolbar changes and stuff like that. We haven't really applied backgrounds, it's gray. So we're going to change that now. You also might want to choose something that has appearances applied. If you haven't applied appearances to your model yet, you can open up like the appearance thing and change it in the rendering tab. There's like a preview with all the colors on the top left next to render, or you can just press A. In this case, I already have a color applied, so I don't really need to change it, but that's how you would change it if you need to. But right now, the background is that's boring, and we want to change that. So Fusion has a couple of set backgrounds that you can choose from, but you can also import like your own backgrounds that you can download in here. I'll send links later. I just asked you for this assignment to use one of the like backgrounds that Fusion gives you, just because like the gray background, like for all the standard lighting backgrounds, kind of look the same to me when I'm grading. So if you can choose something that obviously is not like a solid gray or like a gray background, please do that. But to do that, there is something called scene settings, which is right next to the appearance tab. It's like a sphere with a little like, thing. It's like inside a cube. But if you click it, there's a couple of different drop downs. Um, main one is like brightness, position, and background. I'm just going to leave the brightness as is, but you can see you can change it. If you move the slider, then your part will become brighter and brighter, or the other way around. Um, the main thing we're going to change is we're going to change the background tab to environment. Changing it to environment will allow you to select environment. If that makes sense. So change it from solid color to environment, and then there's a tab right next to the settings on the top that says environment library. You're going to want to click that, and then you can see there's a couple of like standard lighting libraries that are available to you, but if you go farther down, there's other options like crossroads or I don't know, field. I'm just gonna click crossroads today. But yeah, please use one of them. You typically have to download it and then click on it. There it goes. When you click on it, you can see like the background changes and it's not gray anymore. In this case, like this game piece is in the middle of the road. So yeah, raise your hand if you're not here yet. I know it's hard to see me, so I'm just gonna walk around.
So I'm putting in a user now. So basically, the live method, I display available images in my page. So I basically pass it to my files folder, and I number it. So like whatever number I input as so let's select an image. I put a number two, so it basically that works. It works. The thing is, like, I need to maybe make some strings. Alright, let's try the other string. Because like
Yes, so, okay, we actually haven't rendered anything yet, so take screenshots and submit anything because you won't get any points. Okay, so,
it works all the way to it breaks like it breaks at around line 62. Sorry? Okay, it's a flow now. I'll show you what's uh, now this is it's a 62. It doesn't like it. It doesn't like floats. Oh, because when I'm indexing, I need. Oh wait. So now what? This is the
assumption that you haven't submitted anything, yeah, I know that. But basically, once you kind of position your part, yeah, okay, you might want to listen because I'm telling you how to do the actual so once you place your part where you want it to be, there's a couple ways you can render it. You can render it like locally on your computer, and then you'll sound like an airport for like half an hour or longer. But we're not going to do that today. You're going to do it via the cloud. But if you kind of want to get an idea of what it would look like, you can do like a local render on your computer. If you do the in-canvas render, it'll allow you to move the component or the assembly in your render space, and then it'll like kind of make a rough render for you. So if you go, there's like a sphere with like a green button on it, or like a green like arrow on the bottom right corner. If you click that, it'll start to render. Like initially it'll look like really pixely, and then like as you wait longer, it'll get nicer and nicer. Basically, how rendering works is it takes like a pixel, or like it'll take like a space, and then it'll like divide it into other smaller spaces, and it'll continue to do that for as long as you want. So the longer you do a render, the higher the quality it is, but longer time. So typically, like as you render a finer and finer image, it's going to take longer and longer just because there's more like pixels to subdivide, if that makes sense. So that's why like in the in-canvas render, you can still move your component around, but when you move it, it'll be like laggy and it will look really bad. And then when you stop moving, it'll start to render and then it will look nice again, right? So that's kind of how rendering works. You can mess around with it for a little bit, but once you kind of find the spot where you like your model, you can do like you can send it out to Autodesk to do the final render. So when you want to do that, there's like a teapot on the top toolbar. It just says render, and then if you click on it, there's a couple options like the aspect ratio, the image size. I'm just gonna leave it as it is. Um, there's a tab that says render with. One of them is cloud, one of them is local. Because we're students and have the education license, we get like infinite cloud renders, which is really nice. So you can just set it to cloud render, and then for the render quality, you can set it to final. And then you'll see here like cloud credits. If you have like some kind of paid version of Fusion, like a non-student version, you might get like an allotted amount of like cloud credits. But again, for students, you get it for free, so they're unlimited. So yeah, once you have a spot in mind and you positioned it well, you just hit that and then you hit render, and then it'll save it it to the cloud, it'll send it out to Autodesk, and then they'll do the hard work for you for the render. So the computer doesn't have to cry a lot. They'll just do it for you, and then you'll get it sent back. So yeah, unless you have a powerful computer, render locally. Yeah. Um, well, you'll see, like, it'll pop up on the bottom left. You can see there's like a kind of like a timer looking icon right now, or presumably, if you just did it now. Typically, you won't have to wait like 10, 15 minutes, and then it'll get sent back to you, and then you can download it. So, yeah. So when you submit your renderings, like once this comes back to you, you'll want to save the file and then send that for your proof that you can render. People will send me like screenshots of the in-canvas render and stuff like that. Don't do that because you're not telling me that you know how to render. So, like the in-canvas render is like a rough render, but I'm mainly after the render the final renders. So send like download the image and then send that to me. Some people take a screenshot of like a preview of the photo, just like download, and it's send that. So yeah, that's basically how you do that. Um, for your final, you're going to do the same thing, but with your final model. So you're going to submit two renderings, this one that we just did right now, and then the second one of your final. Um, if you look on the rubric, there's an extra credit opportunity if you import like a custom background or environment. Um, I'll send a link to it later if you're interested, but it's basically like 3 points. So if you want to do that, um, yeah, I'm gonna walk around for a little bit. That's basically it. Then we're just gonna move on to this demo, and then you guys can get out of here.
The final project, we should render and send it to you, the whole file, so you can print it.
So, okay, yeah, that's a good question. For the final project, basically what I'm asking of you is you send like your Fusion workspace screenshot like you have done for almost all the other assignments. So for the assignment submission, please do that. And then there's another optional thing that says like submit for printing. You'll want to export your model as a step file and then send it to me. So I guess I'll do that now. It's probably going to be hard to see, but again, I am recording this, so if you want to watch it later, you can. It should just be file, I think save as. Oh wait, no, file export. Yeah. There's like a 3D print option, but you don't want that. You just want to export it for the file type. It defaults to F3D, which is just the Fusion file. But if you scroll down, you can find the step file right above STL. Again, I talked a little bit about STL and step. I prefer step, but my printer, or the slicing software can do both. But your quality or your print quality might be a little bit nicer if it's a step file. So yeah, you just set it to step and then hit export and then save it to wherever you want. Um, yeah. Anyone have any questions about that? Okay, yes. So the final project will be due in 1 week from today, and I'll just say, like, turn it in before midnight, right? So instead of it being like 5:29 p.m. like it has been, you have until midnight on Monday. I realize it is during break, but, hopefully you have time to do it before break so you can enjoy it. Or if you want to do it while you have free time during break, that's also fine too. Um, yeah, your final is due in 1 week. I think some of you have already started, but if you haven't, then that's okay. Again, if there are any questions about how the finals are graded, feel free to ask. But again, the requirements for getting a good grade on it really aren't that high. It's mainly there just so you can explore and challenge yourself to see what you can do. Um, but if you have exams and stuff, I totally understand because I have like one tomorrow and I haven't started studying yet. So if you're like me, then you might have to like bang it out real quick, which is totally fine. But if you have more free time, then I encourage you to try to make something fun. It's other rendering questions? Not, then we're gonna move to the demo, which is, oh, do you have your hand raised? You'll know when it's done when in the rendering gallery. Oh, mine's done. Okay, in the rendering gallery on the bottom of the render tab, there's like typically like the clock icon or the timer icon. Once that disappears and you see like a photo, then your render is done, and then you can click on it and download it. Yeah, whatever image format you like. Yeah, it's just like a big download button. Did it work for you? Okay, yeah, it should come in like the next few minutes. But yeah. Also, I have like a bajillion benchies because I tune my printer all the time. So if you want to take one, please do, because I don't really know what to do with them. But yeah, yeah, feel free. Yeah, I'm gonna be doing a demo now, so if you want to gather by the printer, you're perfectly welcome to. Um, yeah, this is kind of my project that I've been working on for the past 2 years. It's a pretty fun thing. So let me unfreeze it real quick and then we can get it going. Yeah, time to break it. So, the phone. Yeah, they keep on falling out. Oh, yeah, yeah, yeah. Yeah.
Is that a filament or something?
No, it's called a belay. So like this motor pulls the filament and the extruder motors on the extruder and they're not like perfectly in sync. So like when this sensor is triggered, then it'll like move one of them slightly faster than the other. They make it catch up. Okay, I don't really know what I should print. So does anyone have any ideas what I should print? You can find one on the internet and then just print. If not, I'm gonna print a bench sheet. Anyone have a request? No? I could. It'll probably take a while, but I could print it. I could, yeah, yeah. Well, I never like. Oh, wait, I never exported it though. Dude, I keep on like, I never save my files. I don't know if I have it. Oh gosh. Oh, here it is.
Yeah, that should be.
Uh, yeah. These overhangs are like not great though. Let me fix this.
Give them a time.
Okay, yeah. No, not SketchUp. Gosh, that's tiny.
Scale it by like
Come on.
100%.
Why can't I click on it? Oh, there it is.
Third one, third one.
Oh, yeah, yeah, yeah. Fine.
Oh, that's not bad.
And I'll do like 600. Get some really crazy 60K infill action.
You don't want to put it in the middle.
No, I just. Oh wait, I need to turn supports on.
Curry. Let me do yeah. Default to tree line. Yeah. That's just why.
Okay, let's see how long this takes. I low key think I could go bigger. This might be like 30 minutes.
Holy supports. That's fine. I'll get that a good
40
time.
minutes. Okay. Alright, so let's do the temps. How are the temps? Okay, it's almost ready. So basically, you all know how to slice stuff, right? So we sliced stuff last week. I'm using a different program. So this program is called Orca Slicer, but it's based on Prusa Slicer. The only reason why I use it is because it gives a little bit more finer control over like the speeds and accelerations, which kind of becomes important when you're printing fast like this. So this printer I built to be, if you've heard of like Bamboo Labs, which is like a pretty popular 3D printer company, I built this thing to like beat those. So this prints like probably over 30% faster at this point, and I'm getting faster like sometimes when it's not broken. But I fixed it last night and it's running pretty well, so hopefully it runs well for you guys. So we had a request to print the engineering fountain, so this print should take about 40 minutes, but yeah. I mean, if you scale it properly, that would be preferred, but you can adjust. Oh, great. You can adjust the scale in the slicer. So, like, if it's too small or too big, I'm gonna size it accordingly. There it goes. Yeah. Typically, this printer, like, I would send the print jobs over Wi-Fi, but because I'm not at home right now, and I can't connect this to PAL, then I'm just connected via Ethernet. But this printer is pretty nice because, like, on the web, like, on the web address or like the IP address, it'll display all the printer information. Yeah, it's soaking. So like it'll give me like graphs of like the temperature, so I can see any temperature fluctuations. I have thermistors inside the chamber, so it tells me how hot it is inside, among other things. And you know, it gives like real time like feedback on where the printer is and how long it's going to take. Um, So right now the chamber is still heating, so we probably need to wait like another minute or two. But we should get started. Yeah, now we get to awkwardly stand here while this thing heats up. Yeah. If anyone wants some, feel free to come up.
It pulls like what, 6 feet?
I mean, the build volume on this is 300 by 300 by 250 millimeters. So technically 250 is your max. But again, there's a lot of you and only one of me. So if you can keep your final project size like reasonable, that'd be nice. But yeah. Okay, I'm just gonna overwrite this.
These are all 3D printed. Yep. Pretty much other than the hardware, everything is. This is Android. Once that's still kind of relatively pressing the spring to push yes. So your actual this is two from I think it's still warming up. Yeah. We're not. We are not. We are. All of these processes just are and we're legal. If you that's what I was thinking right off the bat. Yeah, there's a three. So this is a modified version of Nerf blaster, and pretty much this these two color ones were the harsh. Everything else is just modified. If you want to go ahead and check it.
Where's the squishy one?
He didn't bring it. Yeah, this one you need to prime back in. I don't know if we're allowed to use it on all, so that's why. You're supposed to like push it back to seal it, and then yeah, if you have a dark use a spring to compress the air to push the bar out.
Would it hurt?
This one, yes. This one depends. So for reference, the rough dart, it hits about like 70 feet per second. This hits about twice as much. And yeah, this one hits over 200.
Could you 3D print a real gun?
Technically, yes, more than likely, unless it's exploding your face before you actually get it. Yes, it's just so you have to buy actual parts to actually.
Most of the ones that people mostly
Mostly gun parts, but plastic, which is what mostly just that's what he's
I wanted this squishy one.
yeah, the squishy one's really expensive. I have one that's like 1 million, but for obvious reasons, I didn't want to use it. Yeah.
Did you not have like?
You really
What? Nerf gun.
Oh, really?
No, we were. Well, Hannah was very much on. We did Nerf gun. We did. You used to have like guns that like fights. Like Nerf gun fights. Yeah. We would the ammo and hide it in different like put it in different spots in the house. We would like take the ammo and hide it in different parts of the house and then like run around and like isolate the ammo from like stash it.
Wait, you guys actually like way better than us. We just like shot up and down the stairs.
I would like to listen. And I was like,
Oh yeah, no,
No, I was gonna say like
because there's some region. So there's yes. So what he did to my that's stupid. It's a 13-minute measure. No, it's a sub 14-minute measure.
yeah. I mean, you use the slicer, but like I wrote the whole,
And this is what PTV is.
like I wrote all of this. This is just like the configuration. Like a lot of it is like online, but like this is just like telling like the firmware like that's just enough like to tell it like and then there's like a main board underneath. So there's a Raspberry Pi that's like the printer and then like you tell the Pi like what so this is a very modified mod. So no, I just called it the drive. I named
built something like this. I would say
I named my other printer, but this is gone. So no, I just someone else at Purdue is using it. Mostly probably like you got all these or something.
Yeah, pretty much.
This is one of like
This one is so that's even
bamboo, like a bamboo of like that is like comparable to this. Like the next one, this is more than the next one, probably like 1.2. But this isn't like you don't need this stuff to do everyday things. Like this is mainly geared for like engineering elements. So that's why I have this like installation and stuff like that. Not like a lot. Yeah, I don't charge a lot, but like I did for enough. So yeah. That's a good one. I need to I need to rescrew my entry. That was why did that happen? Damn, I've never experienced that. All 3D printed. Yeah, I mean the gantry is 3D printed carbon fiber PET. So.
how flexible, like elastic is this material. I want to make like a makeshift string out of it.
Like
And, like if I want to like make like a little same project that like I'll have a separate piece.
I would just we're working on something and just for the final we just submit one part. So yeah, that's fine.
Still doing the same thing, but with a different. I don't know.
That was if you want one of those benches, you can take it.
All of these are better than any bench I've ever seen.
You want to see some materials? Well,
Yeah, oh, yeah, that's more of the stuff that I end up printing.
yeah. It ain't broken down. This is slightly off. It's right.
How does this thing like change material?
Yeah, or like it's
That's when we were trying to push my printer too fast before it was finally tuned. It was a part of the tuning process. It is. See, you can see that it's like it's shipped it in one axis, but just
that's
that
what I'm
one
saying.
axis.
Just one axis.
That's how. See, that's how we tune. It's like oddly specific, but it's good that it's specific.
Really? Like consistently?
That's what I'm working on because mainly the problem is like it's a yeah, one of my jobs I would build big industrial strength systems. I didn't really figure anything out.
So how does it work with
So like I don't have plans right there, but
so it just goes into the same thing?
yeah. So there's supposed to be like 12 of these, and then so I designed this so you can see the filaments going through. So when it cuts it, it ejects it, and then this extra goes into here, so it doesn't tangle the spool, and then it'll move to the next one.
How did you like figure out like Did you get inspiration from other?
Yeah. Lots of other people have designed stuff like this. Like I just wanted to make a nice, like, wanted to like
That's like so cool. Barcodes is so fun. I use that in my education.
I did too. Their print quality is so it's so low maintenance. You just walk up to the printer.
Printer costs are fucking scary though, dude. The Mark II is like 20 grand. They're terrified to break it. We had one in there. Dude, bought it. It was like 100 grand. It was like the FX.
Also, only
So we're gonna put it in like the metal ones too.
but he's gonna try to
That's why I want to get another. He's trying to push the It's just nuts. Apparently, the place I was at this summer, they had 8 of the Formlabs resin printers. They had 2 of them were like the larger ones. I don't really know the size of it. They had 2 Mark IVs and they had one of the big Stratus systems.
yes.
I didn't get to make a lot of my own parts, but an engineer would be like, "Go print this for me." I'd be like, "Sweet."
I gotta make a lot of parts myself.
You will be surprised because these are on Lidl.
It's called
So,
the car wash company.
that's why we used to have
Largest
more secret, like every single
manufacturers in the planet.
That's how like
They work on the location I was at in Minnesota did a lot with chemical distribution. So they right now how it really works is they just have something pulling the system.
The base is very thin.
They kind of fine tune it.
Here, let me show you.
Go through the nozzle. So it's basically like the
Yeah, it's a very thin base. Yeah.
It's kind of like a carburetor. How they're pulling water and but they're trying to make it like fuel injected, so it's automated and everything. So they were going through a big like R&D phase when I was there this summer, so that was kind of fun. Just messing around with like different plastics and water flow and pneumatics and all that fun stuff. So it was cool. But yeah, a lot of printer work, which was fun. Yeah. Go ahead, have a good one. Dude.
Why band to What's the trust code? What's up? Why is the trust code? Yeah, like what's the point of the design? Oh, okay. So it's multiple tests. Yeah, so you're like seeing the first layer, how the first layer is, and this hole is supposedly the right dimension to put like the filaments, and then the test like over here. These are the overhangs.
Oh yeah.
And then how it interacts with holes, and there's straight up bridging because there's like no curves and anything, and this at the end is like it's testing to see how good your cooling is, because if your cooling is really bad, it's gonna look like the whole thing looks like this.
Oh.
Yeah, if your cooling is good, the whole thing will look like this.
Yeah. So this is like you can see here, like this has. And she had bad cooling.
Yeah.
DC, so this is better because DC there's not as much dripping. Like this one, I was curious to see how fast I can print this. So this is 15 shots. This is 15 minutes. This is like a 20. Yeah. There's a guy who's trying to break sub 1.
Run this into the questions.
Yeah, exactly.
Speaking of which, there is like a girl who they literally added like a turbo sheet color for them, and they did all that on their.
Yeah, evolving 3D printer where you get 3D printed parts in where they should be, so just infinite.
I mean, that's what this does. It's the parts. So.
Well, yeah, but I mean, like, it does. It's the fully ambient system where it just moves around by itself and prints at the spot where it needs to be. Fully autonomous.
Okay, this printer, this step is like super corrupted, bro.
Yeah.
Could possibly be wrong with it.
No, dude, look at this. Why? This is like straight up. Oh, what the?
It's floating, yeah.
It's definitely.
Oh no.
Possibly.
You demonstrate.